In this lecture, we take one more example on reduction formula. The question is, if in is equal to integration of x to the power n sine x plus cos x under the limit 0 to pi by 2 with respect to x, then prove that in is equal to pi by 2 to the power n whole to the power n plus n times of pi by 2 whole to the power n minus 1 minus n into n minus 1 into in minus 2. We have given that in is equal to integration of x to the power n whole times of sine x plus cos x with respect to x under the limit 0 to pi by 2. Here we know what is the integration of sine x plus cos x. So we can directly use the integration by part. This is our u, x to the power n is u, and this is v. So let us use that formula. First function x to the power n, integration of sine x is minus cos x plus integration of cos x is sine x under the limit 0 to pi by 2 minus integration uh, under the limit 0 to pi by 2. Then first derivative of x to the power n is nothing but n into x to the power n minus 1, and integration of sine x is again minus cos x, and integration of cos x is sine x under the with respect to x. Let us simplify it. So we have to substitute the upper limit, which is pi by 2. X is pi by 2, so pi by 2 to the power n in bracket minus cos pi by 2 plus sine pi by 2. This is upper limit minus lower limit is x to the power n means 0 to the power n multiplied by minus cos 0 plus sine 0. So this is the first part of the given integration. Now the second part we can write down, we can take n outside minus n and integration of x to the power n minus 1 multiplied by minus cos x plus sin x with respect to x under the limit 0 to pi by 2. Let us again simplify the first part. It is pi by 2 to the power n minus cos pi by 2 is 0, sin pi by 2 is 1, again 0 to the power n is 0, minus cos 0 is minus 1, and sin 0 is 0. Then minus n integration of x to the power n minus 1 in bracket minus cos x into plus sin x with respect to x under the limit 0 to pi by 2. Again simplify it. It is, this one is 0, sorry, minus 0 plus 1 is 1. So we have pi by 2 whole to the power n minus this part is 0. And then again minus n integration of x to the power n minus 1 into minus cos x plus sin x with respect to x under the limit 0 to pi by 2. Now here we again apply the integration by part. This is the first part is nothing but pi by 2 whole to the power n. The second part we are again applying, so minus n we have taken outside. So first function x to the power n minus 1, integration of minus cos x is minus sin x, and integration of sin x is minus cos x under the limit 0 to pi by 2. Then this is not plus, this is minus sine, and derivative of x to the power n minus 1 is n minus 1 x to the power n minus 2, and integration of minus cos x is minus sin x, and plus sin x, integration of plus sin x is minus cos x with respect to x. So which gives us, this is what it is, nothing but this minus and minus if we take outside, it will become plus n x to the power n minus 1 sin x plus cos x whole to the power under the limit 0 to pi by 2, and this minus, and this is plus, but if we take minus sign outside, it will become again minus. Actually, this is minus sign, not plus sign. So minus into minus plus, and again this minus will become minus sign. So this is minus sign minus n into n minus 1 integration under the limit 0 to pi by 2 of x to the power n minus 2 sin x plus cos x with respect to x. Let us again substitute the limit. This is first part is pi by 2 whole to the power n into n pi by 2 to the power n minus 1 sine pi by 2 plus cos pi by 2. This is upper limit minus lower limit is 0 to the power n minus 1. It is n minus 1. And then sine into sine 0 plus cos 0 minus n into n minus 1. And this is nothing but in place of x, it is n, it is n minus 2. So we can write down minus n minus 1 into in minus 2. If we again simplify it, pi by 2 whole to the power n plus n pi by 2 to the power n minus 1. Sine pi by 2 is 1, cos pi by 2 is 0. This is again 0 into sine 0 is 0, cos 0 is 1, minus n into n minus 1 into in minus 2. If we again simplify it, pi by 2 to the power whole to the power n plus n pi by 2 whole to the power n minus 1 into 1 minus, this is nothing but 0, minus n into n minus 1 into in minus 2. So this is nothing but, again, this will become pi by 2 to the power n minus 1. So which gives us pi by 2 whole to the power n plus n into pi by 2 whole to the power n minus 1 minus n into n minus 1 into in minus 2. Therefore, in is equal to pi by 2 to the power n plus n into pi by 2 to the power n minus 1 minus n into n minus 1 into in minus 2. So this is the desired result. Thank you.